Okay, so let's take a look at part 2 of our geometry unit. I'm just going to get the door and get the lights. All right, let's backtrack. Okay. Okay, so last time we looked, these were some of the things that the language, it was really mostly about language, and this was on your diagnostic. So these are some of the words that you're going to hear from math teachers when they're talking about geometry. From the simplest thing in geometry, a point and a plane, to a line segment, a ray. Then there's the difference between a parallel line and a perpendicular line. An angle, an intersection point, a right angle, an acute angle, an obtuse angle, vertices, sides, and a polygon. So really in part 1 it was just all about this language. There's going to be more language today, okay? You need to be aware of these different pieces of language that the teachers are going to use. Okay, so let's start with measurement, okay? The word geometry means to measure the earth, to put numbers on something. So this means that we need to be able to determine if something's bigger or smaller than another thing. That's what geometry is useful for. So it's easy with something like a line. Can I tell if one line is longer or shorter than another? By just putting numbers on the line, okay, like the number line itself. To do this, we have systems for putting numbers on. One of the systems is called the metric system. Another system is called the imperial system. You see this when you grab a ruler. On one side of the ruler, it uses inches and feet and things like that. And on the other side of the ruler, it uses centimeters and millimeters. These are two different systems for putting numbers on things. Here in Canada, we generally use the metric system to measure most things. That's how we put numbers on things. It's the standard unit. In the United States, it's not. In the United States, it's the imperial system. They use inches, but the reality is in our world, it's sometimes a mix of those. Most people don't describe their height in meters. I don't, okay? Most people still use the old imperial system to describe their height. My mother still uses the imperial system to describe how far away something is, like cities. She'll use miles, when for me, I'm more comfortable using kilometers away, okay? So here's a line segment that goes from A to B, okay? To measure it, we're going to put numbers on it, and we're going to use a system for that. So if I put numbers on this from 0 to 17, I can say that this line segment is 17 long. But then the next question would be 17 what? So that's where the system comes in. If it's millimeters, I say millimeters. If it's inches, I say inches. Those are what we call the units that we're using to measure it, okay? This is not revolutionary to you. You've certainly seen this before, okay? But the idea is that we have a standard unit system so that we're all talking about the same thing. So if I say to you, go 5 over that way, it doesn't mean anything to you unless I put a unit on it. If I say go 5 steps, or if I say go 5 meters, or if I say go 5 yards, you actually can then actually figure out how far away I'm talking about. Okay, now in part 1 we saw another way we can put numbers to things is this thing called angles. Whenever we have two lines that intersect, we can use these things called angles. Okay? Now if we have a shape like a rectangle, one other way we can put a number on this rectangle is to measure all the line segments, right? So I can measure each one of them and then add those all up. This is essentially called the distance around that shape, and we generally use the word in geometry to describe that as perimeter, okay? The word perimeter is the distance around a 2D shape. So in this case, it's a rectangle. So I need to measure the distance to go all around it. So in other words, I measure the length of all the line segments. Okay? Another way you can think of perimeter is what happens if I just walked around it? Right? Like if it was this table right here, if I just walked around the edge of this table from the beginning to the end and measured my distance as I walked around, that's perimeter, right? It doesn't have to be a rectangle. It could be any shape that I could just walk the distance around it and I would get the perimeter of that shape, okay? Another way you can think of perimeter, this is the animation that took me so long, was if you took all the pieces of it, put them together and straightened them out, and then measured that one distance, that's also the perimeter, right? It's the distance around that shape. Now, we now know how we can measure one line. We could measure the length. Two lines, we could measure the angle between the two lines. We could measure the distance around a shape, the perimeter. But what if we backtrack a bit? What about a single point? Okay? How do we put numbers on that? So let's start with here again. Okay? Remember, basic geometry starts with 1 point. If I have 2 points, I can create a line. And the second I have a line, a number I can put on that is the length of that line.
That's a line segment, not a line.
That's right. That is a line segment. You are correct. If I have 2 lines or line segments, in this case, let's make them lines, that cross or have an intersection point, one of the things I can measure is an angle. Okay? I can measure an angle in degrees. Okay, so here's 2 ways I can put numbers to things. I can put number to the length of a line segment. I can put a number to the angle of 2 lines that intersect. But then as we get more complex, from simple points to simple lines to simple line segments, we can get up to something as complex as a shape, like this one. Okay? Shapes have vertices, or points. Points and vertices are the same thing. Shapes have lines, or line segments. So the first measurement I can do is I can measure the distance around that shape all the way around, and that's called the perimeter. Okay, but let's backtrack a bit. What happens if I have a single point? What can I measure about that? Can't measure a length, can't measure an angle, can't measure a perimeter. It's just one single dot in space. Now I know the way I drew it, it looks like a circle, so you could think that, but don't think of it as a circle, just think of it as a single point. Okay? So to deal with that in geometry, we have to think about a way to draw that point. So if I said to you guys right now, go and draw a point up on this smartboard, and then I erased it and I said to the next one of you, go draw the exact same point in the exact same spot, and you didn't know where it was, you'd need a way for me to describe where to put that point. Okay? So how do I describe where to draw it? What system do I use? Well, in geometry, the system we use is called the Cartesian geometry system. This was actually introduced by a philosopher named René Descartes, okay? Who in Latin, his name is more Cartesius, okay? That's the way it's pronounced in Latin. And that's where the word comes from. And what he did was he kind of joined up geometry with algebra, what we studied in our last unit. And he came up with this system called the Cartesian geometry system. And it's the one we still use today. This is the one you're going to have to use in grade 9 math. You've seen it before, but let's sort of review what it looks like. You start with a grid. On a 2D plane, a grid. So now that you have a grid, you can kind of pinpoint exact spots on the grid. In order to help you find those points, we have these 2 perpendicular lines that we call the axes. Okay? Or one axis and another axis. Okay? These 2 axes are named the x and the y axes. You'll see those 2 letters come from geometry, or pardon me, from algebra. So that's where he was mixing the algebra stuff in there. And then from those we can use what's called a coordinate. A coordinate is a way to get the exact x and y position using something called an ordered pair. And the way it's written in geometry is to write an x, then a comma, and then a y. And usually those 2 coordinates are placed inside of brackets. Okay, let's expand on this. So we have this system for plotting a point based on a grid and 2 lines, an x, y, and a x, comma, y in what's called an ordered pair coordinate. Now, there is a spot on this grid where the 2 lines intersect, or where they meet, right there. That spot has a name. It's called the origin point, because it's the starting point. This is the spot where you can start your geometry. And that spot has been given the number 0, 0. That's the spot where x is a 0 and y is a 0. But from this point, we can now plot any point anywhere on this grid. by giving it numbers. So for example, if I say, I'm going to give you spot 2, 3. Okay, so I've animated this for you. How do I plot that? Well, we know the first number is x, just like the alphabet. X comes before y in the alphabet. And we know x is this line, the line that goes across. So when we plot 2, we count 2 spaces from the origin point. So from spot 0, 0, always we start at the origin point. Just like an origin story in superheroes, that's where you begin. And I count out 2 spots. So there, I counted out 2 spots. Then from the y, I count out 3 spots. And I find the exact place where I put the dot at spot 2, 3. Okay? I know some of you have done this before, but I know it was also tricky for some of you when I gave you the diagnostic. You had no idea how to do this type of question. You can expect lots of these types of questions in the grade 9 math program. And you got to be able to pull it off. You got to have a system for this. Okay? Now, from here you can plot any kind of number you want. Some of those numbers are positive. Some of those numbers are negative. You could plot spot 0, 0 by just putting the dot right at the origin point. But here, for example, I could plot spot -5, -5, or -3, 2, or 4, -2. One is the x, one is the y, and you start from the origin point to plot the points. Okay, so that gives us one more system. So we can put a number on a length. We can say this is the number. We can put a number on the angle and say that's what the angle is in degrees. We can put a number on the perimeter by counting up the distance all around. And now with a point, the way we can put a number on it is to give it an x and a y as 2 numbers to plot it. And if we can plot points, and then we can draw lines, we can start to do all the geometry here we need to. Okay? But now we got to move to the next stage. Okay? We'll go back to a little bit further. So let's say it's a shape like a triangle or a rectangle, 2 basic shapes. Now, yes, I could determine the length of all the lines, the perimeter. I could plot out the points. But what we're going to look at next is the thing called area. And specifically, we're going to talk about something called surface area. So if we measure the length of a line, okay, we measure the angles, we measure the perimeter, we know about that, okay? But another shape, another measurement we can make is the area. Now, area is important because it's basically how much area, how much space does this shape take up? How much space does it occupy for the whole shape? And this is called the surface area. Now, how this would be important in the real world would be to think of things like how much paint would I put on this thing if this was, say, a wall in my house. I'd need to know exactly how much paint to fill up that space on that wall or other types of things. So that's what we're talking about with surface area. Yes? Yes. Okay? Now, the way you do area, and this is now really getting close to the grade 9 curriculum, this is a big part of the grade 9 curriculum, is to calculate surface area using formulas. Okay, now formulas was something we did in our last unit. Formulas is algebra. So you're going to mix your algebra with your geometry here. Okay? So, as we've said before, formula just means to form a solution. So you're formulating or you're creating a form of a solution. Okay? You do this by taking variables and putting numbers in that were unknown at the time when you were creating it. Okay? Once you have the numbers in there, then you go back to our first unit and you use your arithmetic skills to calculate the answer. You can use tools to help with this, tools like calculators and stuff like that. Okay? So for example, here's a simple area problem. You have a rectangle and you've been given 2 lengths. The length of one side, which is 10 centimeters, and the length of another side, which is 8 centimeters. Okay? To calculate the surface area of a rectangle, you multiply, so you're going to use multiplication to multiply the length of one side by its perpendicular side. Okay? Because in other words, I know that this bottom line is also 10 centimeters. If I multiply 10 times 10, I'm going to get the wrong answer. I have to multiply 10 by its perpendicular side. Now you need to know what that word means. And that was in part 1. Perpendicular means an angle that is 90 degrees away from the other line. Okay? So here's the basic formula. Okay? We can use words like width and length and multiply 8 times 10 to get 80 centimeters. That's the area of that rectangle. Okay? We can write it out. The area of a rectangle is equal to the length times the width. Now this is written in algebra. Okay? So you need to understand that algebra or you can't go any further with a geometry question like this. If you don't understand that LW means length times width, you're lost. Which is why geometry follows algebra generally, because it's using algebra, which is why algebra follows arithmetic, because it uses arithmetic. Okay? So A is the surface area, L is the length of one side, it doesn't matter which side you pick. W is the width of the opposite side on the perpendicular, so it's on its perpendicular side. So here, let's take an example. Here is a rectangle. I'm going to call this the length, 15. I'm going to call this the width, 8.5. But it honestly didn't matter. I could have called this the length and this the width. I'm multiplying those two numbers together and coming up with the number 127.5 for the area. This formula works on both rectangles and squares. Works on either one. Okay? That's how you calculate the area. Now, with a triangle, it's a little bit different. It's a little bit trickier. With a triangle, the formula gets more complicated. Now, with this formula, we're still doing a multiplication, but then we're using this thing that looks like a fraction. Okay? So let me just write this out real quick. Okay? It's HB over 2. Okay? This thing looks like a fraction like 1/2, and that's exactly right. Because if you think about it, a triangle is really half of a square. So that's where that comes from. It's half of a square, or half of a rectangle, depending on the type of triangle you're creating. That's why the thing there looks like that. Now you should also know from our first unit, when you see this, it means the same as divided by 2. It means the same thing. So when you see a fraction, it means the same as division, and so it helps. We also know that this means multiplication. That's what two letters beside each other mean. So understanding that algebra is super important, or you won't understand what this formula kind of is, how you're going to approach it. Okay, so now let's take a look. So we have A, which is the area of the triangle, H, which is the height of the triangle. We'll get into what that means in a second. And B, which is the base of the triangle. Okay, so let's define what these H and B mean. Like, what is the height and what is the base? Okay? They're not necessarily the length of a side. They could be, but they're not necessarily. So I'm going to show you a couple different triangles right here. In this triangle, this is the height. So a way you could think of it almost is like the pole that's holding up a tent right there. That's the height of the triangle. Now here's a different triangle. There's the height in that case. Now in the third triangle, the height in this one is the side. It's the same as that particular side, but not in every case. So when you're given a question about area with a triangle, you're going to be given a number like that, height. Now, base is the length of the side that's perpendicular to the height. Okay, so I'm going to show you that. The way you can think of base also as the bottom. So sometimes some students like to remember B means bottom of the triangle. Okay? But that can be a bit confusing depending on the way the triangle's drawn. So let me show you. In this case, this is the base. This is the base, and this is the base. The base is always the side opposite of the height. Okay? Now I could take this whole triangle and rotate it, and you'd still have the same base and the same height. But in that case, it doesn't feel like it's the bottom, right? So let me show you what I mean by this. Let me try and draw a weird looking triangle. Okay? So I'll just draw it like this. Okay? And then let me take that triangle and rotate it into sort of a strange position like that. Okay, and I know I didn't draw it that well. Okay? Now in this case, if I give you this number, that's the height. That's the height of this triangle. The base of this triangle, when you think bottom, you'd think, well, there is no bottom to this triangle. Well, there is, because the base of this triangle is perpendicular to the height, so the base would be down here. This is the base, from here to here. That's the base. Whereas the height goes from up here to here. And again, this whole thing could be rotated. Could rotate all this. And those sides don't change, right? Notice here, this is the base and this is the height. But with any triangle, those numbers can be different, right? So, okay, in this case, I could say this is the height. So if that's the height, this is the base. So as you're going to see with geometry, a lot of it is labeling the stuff first before you start figuring out answers. That's really important. So in the case of triangles, it's a lot harder than rectangles in the sense that we have to label those sides first. We're actually going to try and do a whole presentation on triangles next week as our last presentation. Okay, so now that we know that, we can calculate the rest. So if we now have these numbers, if we have a height and we have a length for the base, we can put them into the formula, multiply height times base, and then divide that number by 2 to get our answer. So surface area with a triangle is a little bit trickier. You got to kind of figure out what's going on there. So if a teacher doesn't give you this height, you can't answer the question. You can't figure out what the height is, or sorry, what the area is until you get that number. Okay. Now, what happens if it's a 3D shape? What if it's not a 2D shape? Well, to calculate area of a 3D shape, you have to do each side. So if you think of like a die from dice, like one die, how many sides are on a die? Come on, you guys know that. Not like six. There are 6 sides. So you have to add them all together, okay? This would be like an example if you were going to wrap a present. Say you had a box, a rectangular box, 3D box, and you had to figure out how much wrapping paper do I need to cover this box. You'd be figuring out what the surface area is. You'd be calculating that, okay? So there are lots of practical examples of why surface area comes into the real world. But here's how it basically works, okay? So here's a 3D shape. Say I'm given these 3 numbers, okay? So if it wasn't a 3D shape, it was just this 2D rectangle, you could calculate area just by multiplying length times width. Yes? Sure. Okay? But now that it has 6 sides, we got to do 6 different areas. So think of it this way. Okay, well, here's the shape. So I'll pull off one of these rectangles, and I'll calculate the length times width, and I get an area of 100, 12 times 10. Then I'll pull off one of the other rectangles, say that one, and I'll multiply out the area. So 5 times 12, 60. Okay? But now I know something else. I know I got one more side to calculate, that side. And I'll do the calculation, which is 5 times 10, or 50. But remember, this side appears twice. It appears here and over on the opposite side. And all of these appear twice. So really, I could just add them all up and start multiplying by 2. 2 times 120, 2 times 1 times 60, 2 times 50. And then I get 240, 120, 100, and add all those up together, and I get the number 460. So the surface area of this 3D shape is that calculation. But there's also another way you can do this. And this formula that I'm about to show you is right in the grade 9 curriculum. Another way you can calculate the surface area of a 3D rectangle, and in the grade 9 curriculum they call it a prism, okay, is using this formula. The area equals 2b plus ph. So now here you can see where in the grade 9 course they're going to make it a little more complicated. Now you have to think, well, what does b mean and what does h mean? Well, just take a guess before I reveal to you. Base and height, that's right. So b is the area of the base, okay? H is the height, and P is the perimeter of the base. I forgot to ask you guys what P means, okay? So here's how you would calculate it using that formula, which again, you wouldn't have to. You could go back and do this one, which is a little more work, but if I use this one, here's how I do it. The base is 10 times 12. The perimeter is 12 plus 10 plus 12 plus 10. That's the distance around. Then I plug in the area, 2 times 120 plus 44 times 5. Keep calculating, and you know what I get? The exact same answer, 460, which was the exact same answer I had when I did it this way. Okay? But here's where it gets confusing, and I'm guessing when you guys were sitting in the grade 9 course and this formula got popped up on the screen, you're lost if 1, you can't do the algebra because you don't know that 2b means 2 times b, okay? 2, you can't do the algebra and you don't know what these letters mean in the context of the question. So that's where I'm trying to help you guys, is really trying to grasp what those mean. Yes? Okay. Okay, last thing to show you guys today is this thing called volume, okay? In the 3D world, we can also measure this thing called volume. What volume is basically the amount of space a 3D object takes up. Another way you can think of it is when you fill up a 3D shape, how much does it take? So this is really important. Volume, for example, when you have a car, when you're filling up your gas tank, that's the volume of your gas tank, okay? Volume is a measurement that only applies to 3D shapes. So you don't do volume when you're dealing with 2D shapes. That's when it's area, okay? And basically the formula is pretty simple. So we're ending on a simple note. Volume is length times width, which is area, times height. So you only have a height when you have a 3D shape. So here's an example. Same shape we just saw. I have 3 numbers. One's the length, one's the width, one's the height. It doesn't really matter because I'm multiplying them all together and I'm coming up with the number 600. And that's my volume. Okay? Last thing, I guess there was one more thing, is now that we're dealing with the 3D world, okay, you have to think about how you look at things in 3D. We live in a 3D world, but when you're dealing with math problems on a piece of paper, the paper is not 3D. The paper is 2D. So when it's drawn on a 2D plane or on a 2D piece of paper, you have to think about how to draw that thing, okay? You're actually creating an illusion. This is a picture from my art class when I did it. In art, you are creating the illusion of 3D when it's not really 3D because you can't make 3D unless you're making a sculpture. On paper, it's always going to be 2D, okay? Artists know this, so they create the picture to look like it's in 3D, okay? And that's going to be something that you're going to be required to do in math class, but you're not in art class, so it's not about how you kind of draw it. And so these are some of the words you're going to hear in geometry class when talking about top view, front view, side view, base view. So these are the ways you look at an object. I'm not going to read all these to you right now because I'm hoping you've seen these before, okay? But I'm going to show you an example. So here's some simple cubes. They're drawn to make the illusion that it's in 3D. But if I wasn't able to draw them in 3D, how could I draw them in 2D? Well, I could say, draw them from the front. And they would look like this in 2D. That's how that shape would look in 2D from the front. Here's how it would look from the right side. So if I was just coming around the right side and drawing the shape, it would look like that. If I was coming around the top, it would look like that. And if I was looking at it from the bottom or the base, it would look like that. So you're going to see this type of thing in grade 9 is they're going to show you these types of sort of simple drawings like this and have you create 3D shapes or vice versa. Take a 3D shape and create 2D shapes. This is really a matter of practice to be able to pull this off. One way you can help with this is this thing called isometric dot paper. You've seen me do this before. The isometric dot paper allows you to kind of more easily create the illusion of 3D by just sort of drawing things like that. Some people find it useful, others don't. But it's something that you want to practice a little bit as you get used to working in geometry. Okay, this is real world as well. This is what people who make house plans do. They say, this is what the house is going to look like in 3D, but this is what it would look like if you looked at it just from the top, which is what a floor plan is, or a blueprint. That's what those things are, is those different views. All right, let's wrap it up. Today, what I said to you guys was these words: perimeter, Cartesian system, coordinates, origin point, area, and volume. Those are the words you need to know to move forward in the geometry. I gave you some methods. I gave you 3 formulas. Area of a rectangle, 4 formulas actually. Area of a triangle, area of a 3D rectangle, and the volume of a 3D rectangle. Those are the 4 calculations and the 4 methods you need to work with this language for today's assignment. All right.